All microcontrollers have a general purpose input-output peripheral. So the Gpio peripheral is usually split into what we call a series of ports. So each port contains several digital pins that can be connected to external devices. Now, these external devices are normally things like LEDs and buttons and switches and so on. So each pin can be configured to be either an input or an output, hence the name general purpose. So as I've said, these pins are digital, which means they can either have a kind of logic 0 or a logic 1 on that pin. So the logic 0 corresponds to 0 volts on the pin, and a logic 1 will correspond to 3.3 volts on the pin for the case of the NXP LPC 17668 microcontroller. So look at the block diagram of the microcontroller. So we can see inside they've got the core, this is like the CPU. We've got our flash memory where we're storing instructions, and our RAM where our variables and so on will be stored in the code. And then we've also got these peripherals connected via this bus system. And you'll see that one of the block diagrams, one of these blocks is a Gpio block. So this is connected to the core through this multi-layer advanced high performance bus matrix. So basically this just means this is connected up to the core here. So all the circuitry for the actual physical pins are inside this block. So look at the picture of the actual LPC 17668 embed development board that we're using as part of this course. We can see the actual board here. So this is our microcontroller, and you can see all these silver, these are the actual pins on the microcontroller, and they're actually connected up. Well, this is too small essentially. This is probably the size of your thumbnail. It's too small to use. It's you can't plug it into a breadboard. So that's what this development board is for. So all these silver things here, they're actually pins what allow us to plug this into a breadboard. So this development board plugs into a breadboard, and then most of these pins on the actual board, you can see close with a look. There's various tracks on the PCB, so you'll be able to see that the different pins are routed, to some of these pins on here, for example. So by plugging into the breadboard, it gives us access. Plug this into the breadboard, and we can plug, connect wires to these pins here, and it will give us access to the actual pins on the microcontroller. So this is showing the pin mapping. So we've got the top left, we've got our power, so we've got ground and V in. So you can see for V in you can apply voltage in the range 4.5 to 9 volts. VB is for battery, and I think some kind of reset type pin. We don't really use it. On the top right we've got the 3.3 regulated output voltage. So if you put say 9 volts in input in here, this will give us a 3.3 volts on this pin. Some voltage regulators here, and there's also this 5 volt USB 8, because you can also power, rather than powering it through V in, you can also power via the USB cable. So you can plug in a USB cable here from your PC, and then when a cable's plugged in there, we'll get the 5 volt USB output power here as well. And then the rest of the pins, all these different coloured boxes, show us the different peripherals and which pins they're connected to. And essentially all these small blue boxes, so P5 up to P30, can all be used as Gpio. So we can use these as either inputs or outputs. And you will see that some pins, share functionality. So inside there's, essentially different peripherals multiplexed onto the same pins. So we can either use pins 9 and 10 for inputs and outputs, or we can use them for serial, for example, or I2C. So some pins have multiple functions, but essentially all these blue ones we can use for Gpio pins. So this is where the actual map. So on the embed itself we've got the P5 up to P30, and then there's also the 4 LEDs on the board. So go back here, there's 4 LEDs on the bottom what are connected to pins, because obviously we can use these LEDs as outputs kind of built in on the board. So we can see the pin, the actual kind of what they correspond to on the actual microcontroller. So this is the embed pins, and then these two columns here are the pins on the microcontroller. So P09 means port 0, pin 9, port 0, pin 8, and so on. So we've got this Gpio peripheral, and it's as well, that and all the other peripherals are controlled by a series of registers. So these registers are inside the actual Gpio peripheral in the microcontroller. So the registers in these ARM Cortex microcontrollers are typically 32 bits wide. So each register contains 4 bytes or 32 bits, and then each register has got a unique address in the microcontroller memory map. So we'll see on the next page, the GPIO registers are in the range 0x2009C000 to 0x2009FFFF. So in this range of memory addresses, these correspond to the GPIO registers, and then we can control the behavior of the GPIO peripheral by writing particular values to the registers. So imagine this picture at the bottom here. So this is the kind of bit number. So this is this is our register here, and this is a bit number. This is just labeling each one. So we can either in each bit in that register we can write ones or zeros. So you can put 32 ones or zeros in here. And when you look in the data sheet, you'll find each of those bits will kind of configure some behavior to do with the GPIO. So look, this is a memory map. So we've got our the flash memories here, and we've got RAM, some more RAM here, and then this is where the GPIO sits. So in these are the addresses. This shows us the address here. So all the different peripherals, you can see the kind of offset. They've all got different. There's all different memory ranges. So the GPIO sits here. So there's various registers that we need to configure when we're using the GPIO. The pin select. So this determines which function on the pin to use. So we saw before some pins have multiple functions. So by writing specific bits in the pin select register, we can control which function to use on a specific pin. There's also a direction register. So this determines whether the pin acts as an input or an output. So we've already seen the general purpose, they can be both. So say for example, if you write 0 to a particular bit, the bit will be an input, and if you write a 1, it'll be an output. There's also a mode register. So this enables and disables pull up or pull down resistors, and we'll see this a bit later. There's a pin register. So this is what we read this register, because this contains the current state of the pin. So if that pin's connected to 3.3 volts, if you look inside a specific bit in that register, that'll contain a 1 because it's a logic high. And if the specific pin is connected to 0 volts, for example, if you read that bit in the register, it'll be a 0. So that register tells us if each pin is connected to the logic 1 or a logic 0. Then there's also a set register. So if we want to make an output pin, well, assuming we've created in the direction register, we've set a specific pin to be an output. By writing that specific bit in the set register, we'll make that pin high, so 3.3 volts will appear on that pin. And then by writing, or if you want to make it 0, you write a 1 to the specific bit in the clear register.